Okay, so let's get started. We're going to be taking a look at working with our fuel injection timing programming found in our Motec M1 system. Now, the focus of the tutorial is going to be on port injection engines, but we will be touching on the fuel injection timing within a direct injection engine because it's handled differently in terms of what we program and what the values actually represent. Let's jump in here and take a look at where we can find our fuel injection timing programming, and we'll talk about some of the concepts and fundamentals of what injection timing represents, what we need to know, and then we're going to be utilizing an Excel spreadsheet calculator to further refine and figure out what values we need to actually place into the table as a starting point based around our camshaft profile that we're running in our engine. So injection timing will be tied into our intake and exhaust valve opening and closing events, which we can find the information from a cam manufacturer and populate that into our Excel spreadsheet. Okay, so we're gonna move here from our fuel tuning page under the workbook I provide for the M1 training course. So we're gonna move all the way over here into our injection timing page. Now in our injection timing page, we're gonna find we have a whole bunch of tables that we can deal with here, calibrate and tune. We're only focused here on our fuel timing primary main table. Now this table is where we call out our injection timing. Depending on what we populate here into our timing primary, the edge is going to be what these degrees actually represent. When we're dealing with a port injection engine, we're always going to be choosing end of injection option. We do have the option to select start of injection, and that's going to be what we choose for a direct injection engine. And we'll briefly talk about the direct injection engines and start of injection in a little bit as to why we actually choose start of injection. But end of injection is going to be the end point where we want to stop spraying our injector at. The reason why we choose this option on a port injection engine is that we have our injector pulse width moving pretty dynamically as we're at a given RPM and load range. So we can see as we're riding in our main VE table, as we go up and down in the table, engine speed, manifold pressure, we're going to find the VE value or the estimated cylinder filling changes, and therefore the injector flow, injector pulse width changes. Because we have such a dynamic moving pulse width, we have to have a point of reference where we want to go and kind of call out things to base everything around. So that's what the injection timing represents. It's where we want to call out the end of injection point, and then the start of injection will be floating or variable. So it can, depending on the pulse width length, it'll move anywhere between, let's say, 50 to 150 degrees before this point. Could even be even larger than that, depending on what the pulse was at. So this will make a little bit more sense once we take a look at our next thing coming up on screen. That's going to be just a quick schematic of what these degrees represent when we're calling out end of injection reference for this port injection engine. So looking at this, we're going to find that we have a couple things on this schematic. We have the degrees relative to the scale that we're referencing here for our injection timing. We also have our different intake strokes, and then we also have labeled here whether the piston's at top dead or bottom dead center. So looking at this from left to right, we can see all the way on the left we have 0 degrees, and that's going to be where the power stroke starts. We know the piston there is at top dead center. As our piston moves down to bottom dead center, that's going to be the equivalent of 180 degrees within this cycle, and then we'll see we're going to be starting into our exhaust stroke. Then we'll find the piston's going to move up to top dead center. We'll be at then top dead center between exhaust and intake stroke. That's 360 degrees reference. Then we find we go through the intake stroke. The piston goes to bottom dead center. We're at 540 degrees. Then we move into our compression stroke, and then we can find as the piston goes up to top dead center, that's 720 degrees. And then we find that it wraps around, so 720 degrees within the combustion stroke, so that top dead center is the same as 0 on the power stroke. So it just begins essentially the engine cycle again. Now the reason why it's important to look at things relative to this scale, because the values in the table here will make a lot more sense. So looking here, if I'm calling out a value of something like 414 degrees, that'll be saying that we want to have the end injection point happening somewhere in the intake strokes. That's where the pulse was going to end. But it can essentially begin the start point where we want to spray the injector anywhere between the intake stroke, the exhaust stroke, and the power stroke. It can essentially calculate things all the way back. And in fact, if we have a large enough pulse width, it can actually even stretch into the compression stroke. Now, the intake valve is only going to be open somewhere at the end of the exhaust stroke and somewhere in closing somewhere at the beginning of the compression stroke. So we have a finite window of where the fuel can actually come into the engine. However, because it's port injected, we're going to be firing the fuel on the back of the intake valve. The fuel can be fired and sit there to the next engine cycle and actually then get into the engine. So on a port injection engine, we can do 100% duty cycle, and we want to be specific with our injection timing to try to get the fuel to be timed so that it meets the intake valve, the back of a closed intake valve, right about the point where it's going to open. That's going to be essentially what we consider an optimized point. We can also spray it into an open intake valve as well, but we want to get into that specific window ideally. Now, depending on what the total pulse width is that we're calculating from our air and fuel model, again, we might find that we're outside that window. So if we're at very high injector pulse widths at something like 50, 80% duty cycle, the injection timing is not going to really matter much because the fuel will ultimately get into the engine either way within the next engine cycle. But when we're talking about low pulse widths, low engine speed, so part throttle cruise idle condition, the injection timing does play a pretty large role in how the engine will run and the fueling efficiency as well for the engine. So we like to be specific with that.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.